Hi, I'm Kristen Hess. I'm going to talk to you about some math concepts using 3-column notes. Today we're going to talk about regression for power and linear functions. I'm specifically going to talk about homework from chapter 3.5, question number 5, or 3.5.17/GC. So this question asks about finding a power function, finding a linear function, both that model the same set of data, and visually determining which function is a better fit for the data. There's our data. First, we need to understand what is a power function. A power function is a function basically where x has an exponent. So here's a couple of examples. So now we're going to use a Pearson's MyMathLab example. So here's the problem that we're going to be solving. You can see that I've already started working on it. You're going to want to click this box here and either copy to a clipboard, and you can copy it, or you can open it in Excel. Once you've gotten it in Excel, you'll want it to look something like this. You'll left click and drag to highlight all the data. Notice there's a green box around all the data you're using. And the X isn't highlighted, but that's okay. You'll go to Insert and select a scatter plot. When you click off the data and left click on one of the dots, you can go to Add a Trend Line. You're going to select the power function because that's what the question's asking about, and display the equation on the chart. If you want to make it bigger, you can highlight it and go to the Home tab and make it larger. And now you can put all of this into Pearson's. You take that 3.75746 and put it in for the coefficient and the exponent. So now let's talk about a linear function. A linear function is when you have an x and a y, the x doesn't have an exponent, the y equals mx plus b. And here's a few examples. So now when we come back to our Pearson's problem, we want to find the linear function. So we're going to do the same thing we did before. We're going to use Excel. We're going to left click to highlight the data. Click on Insert, go to the scatter plot, and it's going to put it right on top of the previous graph. We're going to keep the other one there for later. When you click off it and then right click on one of the dots, add a trend line. We want linear, and you're going to display the equation on the chart and display the r squared on the chart. And again, you can make this larger. And then we will transfer this over to the equation. So we'll put this 7.8 in for the coefficient in front of the x, and the minus 7.4 in for the y-intercept. The last piece is which one is a better fit. So when we think about the best fit, there's a few different things we can think about. We can use correlation. So for example, in our graphs, we had an r squared, and if r squared is close to 1, that's a strong fit. When it's closer to 0, there's no fit. So when we look at our data, the r squared for the linear function was 0.9475, and for the power function, it was 0.9639. They're both very good fits, but the power function was a higher r squared value, so it's a better fit. So when we come back to our data, we're going to narrow this down to the options that have the power function. So we want either the power function is a better fit because the y value appears to be increasing more rapidly as x increases, or the power function is a better fit because the y values appear to be increasing at a slower pace than x increases. So now, to determine which one of these makes more sense, we're going to look at the data. X increases at a steady rate from 1 to 1 to 1 to 1. Y from 4 to 9 is a 5. From 9 to 11 is a 2. From 11 to 21 is 10. 21 to 32 is 11. And 32 to 43 is 11. So overall, these y values are getting further and further apart. So that means that our y values appear to be increasing more rapidly as x increases. So in summary, we've talked about what a power function is, what a linear function is, and we've modeled how to find the trend line and r squared in Excel for each. We've also discussed how to determine the best fit. Feel free to reach out with me for any future questions. Thank you.